Okay, so this is where we're aiming to get to, is that we want to be able to define a superellipse with a certain number of points. So what we need to think about is we're going to be working as though we were moving around in an anti-clockwise way. Each point is going to be a point on the curve, and we want to be able to calculate what is the angle between 2 points and the center. So we're interested in, if I was to draw this now, we're interested in calculating, let's see here, we'll just roughly draw it in. We want to know what that angle is. So if we are, in our model, if we're defining 53 points all the way around, what's that angle going to be? So let's think about how we can start to define that. Let's just pull back the script. So we're going to make a new parameter. This time it's going to be a double. We're going to call it increment. So it's the angular increment as we move around the circle. And what we need to do is we want to say it's going to be math.pi. So what we're doing here is we're actually using a built-in library of mathematical functions. So we can say math.pi. This exists inside the script. We need to multiply that by 2. So this is an angle in radians, math.pi times 2 divided by the number of points, and that gives us what that increment size is. So if we want to know, as we move around the circle, what is the current angle, we're also going to need another parameter that we're going to call theta. This is our total angle. So this is the angle that describes exactly where we are. We're going to set it to 0 right here, and in order to calculate theta for each of our steps, we just need to say it's going to be I, which is the step number, multiplied by the increment. So that will give us the angle. So let's just think about that. Let's just click OK here. So switch back to my other model. So this means that right here, when we're at step 0, the angle is 0. This would be step 1. But then what we're trying to set up is something that gives us the ability to say, okay, what is this? What now is this angle here? This is 0, 1, 2, 3, 4, 5, 6. So we say the increment multiplied by 6, and that gives us the angle. So we've got the angle there, and we've got this thing called count loops that we don't really need, so I'm going to get rid of it for now because that was just a test. But let's imagine, before we go in and do the superellipse, let's just imagine all we want is a circle. So how do we define a circle in terms of points, where we have a set number of points, and let's say r is our radius. So here's a good reference. X equals r cos t. In this case, t is our theta, the angle, and y equals r sine t. So we can use an equation like this. So let's just have a look how we would set that up. So we first of all need 2 new parameters. One is going to be x, and the other one is going to be y. We have to set them both to be 0 to begin with. So in here we said x equals r times by math dot cos theta, y equals r times by math dot sine theta. So that's our version in C# of this parametric equation. R equals r, x equals r cos theta, y equals r sine theta. So we're using a library of mathematical commands that give us access to sine and cos. Now, nothing's going to come out right here because all we've got is some calculations for x and y. The thing that changes every time is theta. If we actually want to see these points, we have to figure out a way of outputting them back into Grasshopper. And what we need here is we're going to make a data tree. And that data tree is going to be full of 3D points. And we're going to call it points. And we have to declare it here as being a data tree. So this is us initializing a new data structure, a new data tree of point 3Ds. And then for each step of the loop, we're going to make a new point 3D that we're going to call, it's going to be a temporary point, and we have to say that that new point 3D is a new point 3D, and it's yet to be defined. We also need to say that this is going to be a new data tree. So now what we've got here, so this is a Rhino object, point 3D, that we also use in Grasshopper. So when we've got an x and a y, we can say, right, temp is going to be a new point 3D, and you can see here we're actually pulling up from the Rhino library that it's going to be a point 3D, and gives us some indication that we can define this with a double x, a double y, and a double z. So straight off we can put in x that we've calculated as being r times math.cos theta, comma, and y that we've calculated. We're not using z just yet, and so we have our point defined. Now that point we now need to add to the data tree, so we can say points, which is our data tree, dot add temp, and then we're going to use b and set that equal to points. So what we should see, although we haven't got anything controlling r just yet, is a circle. So let's click that. Okay. Oh, just switch to another file. Let's just close that down. So now if we set, you can see here that b coming out, they're all 0 because we don't have a radius just yet. Let's set the radius to be 20.55. Let's just find our points. So this is a scale in millimeters. So right here you can see we've now just written a little script that generates points in a circle, and we're going to continue in the next video to adapt that to become points that are a super